For this problem, you are told that RP is 8, and I'll put this in blue so we know it goes with the blue figure. We're told QP is X. We're told that R prime P prime is 12, and that Q prime P prime is 15. First things first, we see we're going from the blue to the red, so clearly this is an enlargement. What we need to recognize is that whenever we are dealing with a dilation, we get similar figures where we have a constant ratio. So 15 to X, side Q prime P prime to QP, is going to be in the same ratio as R prime P prime to RP. So 15 to X equals 12 to 8. There's a number of different ways you could solve this. Probably most straightforward is to cross multiply. You get 12 times X equals 15 times 8, which is 120. Divide both sides by 12, you get X equals 10. So it's an enlargement where X equals 10, and that means our ratio is 15 over 10, because we always put the number that belongs to our new figure, our image, over the original, or 3/2. So K equals 3/2. And there we have it. It's an enlargement. Our scale factor is 3/2, and X equals 10. Okay, matrices. This is probably one of the first sections where the matrix stuff is really easy. So you're gonna love this part with the matrices. What we see with matrices is we can do scalar multiplication. And scalar multiplication is the process of multiplying each element of a matrix by a scalar. And the scalar is a real number. For example, here we have the matrix. It's a 2 by 3, and we're multiplying by the scalar 4. What this means is we take 4 and we multiply it by each element in the matrix. So our resulting matrix is 12, 0, 4, 8, -4, -12. And that is your final answer. To give you some practice, go ahead and try this example 2. Simplify the following product. You have 2 examples here, so you have 2 matrices both being multiplied by a scalar. Pause the video and then resume when you're ready to check your solution. For this first one, I'm multiplying through by 5. I get 10, 5, -50, 15, -20, and 35. For the second one, I multiply through by -2, which gives me -16, 4, 0. And on the bottom row, I get +36, -20, -28. Those are my solutions. Alright, example 3, scalar multiplication and dilations. What we see is that we can use a scalar for a multiplication with matrix the same way we use scalars in dilations. So I know you, or hopefully you remember, that to represent a dilation with coordinates, we multiply by our scale factor. So we end up with, let's say we're scaling by 3. Our ordered pair goes to 3x, 3y. Well, with matrices, we take the matrix and we just multiply by the scale factor up front. So we have vertices of quadrilateral KLMN. Our K is -6, 6. L is -3, 6. M is 0, 3. And N is -6, 0. There's my matrix. We're going to use scalar multiplication to find the image after a dilation with the center of the origin and a scale factor of 1/3. So we go through the multiplication, we get -2, -1, 0, -2, 2, 2, 1, 0. There is my image matrix. K prime, L prime, M prime, N prime.